the solar system stage, the planet-forming era. Subsequent to the birth of the solar system, a period of diminishing solar disgorgement ensued. Decreasingly for another 500,000 years, the Sun continued to pour forth diminishing volumes of matter into surrounding space. But during these early times of erratic orbits, when the surrounding bodies made their nearest approach to the Sun, the solar parent was able to recapture a large portion of this meteoric material. The planets nearest the Sun were the first to have their revolutions slowed down by tidal friction. Such gravitational influences also contribute to the stabilization of planetary orbits while acting as a brake on the rate of planetary axial revolution, causing a planet to revolve ever slower until axial revolution ceases, leaving one hemisphere of the planet always turned toward the Sun or larger body, as is illustrated by the planet Mercury and by the Moon, which always turns the same face toward Urantia. When the tidal frictions of the Moon and the Earth become equalized, the Earth will always turn the same hemisphere toward the Moon, and the day and month will be analogous in length, about 47 days. When such stability of orbits is attained, tidal frictions will go into reverse action, no longer driving the Moon farther away from the Earth but gradually drawing the satellite toward the planet. And then, in that far distant future when the Moon approaches to within about 11,000 miles of the Earth, the gravity action of the latter will cause the Moon to disrupt, and this tidal gravity explosion will shatter the Moon into small particles, which may assemble about the world as rings of matter resembling those of Saturn, or may be gradually drawn into the Earth as meteors. If space bodies are similar in size and density, collisions may occur. But if two space bodies of similar density are relatively unequal in size, then, if the smaller progressively approaches the larger, the disruption of the smaller body will occur when the radius of its orbit becomes less than 2 1/2 times the radius of the larger body. Collisions among the giants of space are rare indeed, but these gravity tidal explosions of lesser bodies are quite common. Shooting stars occur in swarms because they are the fragments of larger bodies of matter which have been disrupted by tidal gravity exerted by nearby and still larger space bodies. Saturn's rings are the fragments of a disrupted satellite. One of the moons of Jupiter is now approaching dangerously near the critical zone of tidal disruption and, within a few million years, will either be claimed by the planet or will undergo gravity tidal disruption. The fifth planet of the solar system of long ago traversed in a regular orbit, periodically making closer and closer approach to Jupiter until it entered the critical zone of gravity tidal disruption, was swiftly fragmentized, and became the present-day cluster of asteroids. 4 billion years ago witnessed the organization of the Jupiter and Saturn systems much as observed today, except for their moons, which continue to increase in size for several billions of years. In fact, all of the planets and satellites of the solar system are still growing as the result of continued meteoric captures. 3,500 billion years ago, the condensation nucleuses of the other 10 planets were well formed, and the cores of most of the moons were intact, though some of the smaller satellites later united to make the present-day larger moons. This age may be regarded as the era of planetary assembly. 3 billion years ago, the solar system was functioning much as it does today. Its members continued to grow in size as space meteors continued to pour in upon the planets and their satellites at a prodigious rate. About this time, your solar system was placed on the physical registry of Nebadon and given its name, Mormatia. 2,500 billion years ago, the planets had grown immensely in size. Urantia was a well-developed sphere about 1/10 its present mass, and was still growing rapidly by meteoric accretion. All of this tremendous activity is a normal part of the making of an evolutionary world on the order of Urantia, and constitutes the astronomic preliminaries to the setting of the stage for the beginning of the physical evolution of such worlds of space in preparation for the life adventures of time.